All right, so in this example, we're being asked to determine y prime, or dy dx, for the following equation. Y is equal to 2x to the fifth plus 4xy plus 4y squared. Now something tricky here is don't be fooled by this. You look at this, you see y equals, etc. And you might be tempted to just go, oh cool, I just take the derivative and I'm done. Well, in a sense, yeah, you just take the derivative. But notice, you still have y's on this side. And there's no way you can solve just for y by itself, because you've also got that pesky y squared in there. If it wasn't for him, you could actually get all the y's together and manipulate it. So instead, we have to do this via implicit differentiation. So let's start. I simply do d dx on both sides. So I'm going to go step by step here to make sure we don't lose anything. Of this whole function over here. Okay, so now over here that's just going to be dy dx. And now that's going to come inside to each one of these terms. So I'm going to have d dx of the first term plus d dx of the second term. Now of course, if you're super good at your calculus, you can skip all this. I'm just being detailed. d dx of 4y squared. Okay, so let's go through this. I've still got dy dx on this side. This just involves an x, so I can just do the straight derivative, bring down the 5 times 2, that's 10, lower the power, that's going to be x to the fourth. This right here is going to be product rule, so let me write it out. 4x times the derivative of my second term plus the derivative of 4x times my second term. Now, of course, you could have just factored out the 4 and not included that, however you want to split that constant up in there. And then plus the derivative of this. I'll go ahead and do this one. This one's fairly straightforward. I bring down the power of 2, so I have 2 times 4 for 8 times y. But then since y is itself a function of x, I'm doing the chain rule. And so I would get dy dx. Imagine if this had been sine or something. So if it was sine squared, you'd do 2 times 4 and then leave y alone, so you'd have sine, but then you'd multiply by the derivative of that, right? So you'd have times cosine. So the same thing's going on here since y is a function of x. Okay, so now equals 10x to the fourth plus, well, this is going to be 4x dy dx. And this is just going to be plus 4y, right? Derivative of x is just 1. Plus 8y dy dx. And of course I have a dy dx on this side. Okay, the hard part, the taking the derivatives done. Now what I have to do is get dy dx by itself. So I'm going to move these two terms that have a dy dx over here so I can factor it out. And so that's going to look like this. I'm going to have dy dx. I'll bring this over, so minus 4x dy dx minus 8y dy dx. And that's equal to what I left over here, which is 10x to the fourth plus 4y. I can factor out this dy dx now. So I take that out. I'm left with 1 minus 4x minus 8y is equal to 10x to the fourth plus 4y. In the final step, I'm just going to divide both sides by this 1 minus 4x minus 8y. So that's going to give me that pink's not very visible, so we'll go back to orange. dy dx equals 10x to the fourth plus 4y all over 1 minus 4x minus 8y. And there we go. Now, one thing that students have trouble getting used to is the fact that when you do implicit differentiation, sometimes your derivative, your dy dx, still has y's on this side. That's okay. Sometimes you might be able to sort of back substitute and get rid of that, but usually not. Remember, the whole reason we had to do implicit differentiation in the first place was because we couldn't isolate the y and get it by itself. And so of course that's going to trickle down and cause problems with the derivative as well. So problems in the sense that you've still got a y left. So there we go. To do implicit differentiation, just take the derivative of everything and just be really careful with your chain rule and remember that y is a function of x everywhere you see it. Collect everything together, solve for your dy dx, and there you go. That is this example.